Here we go, ladies and gentlemen, with a video on interest. And we're going to talk about two different interest formulas. We have our regular compounded interest formula, and A is going to be the total amount you have in the bank after interest and everything. P is your initial investment or your principal. R is going to be your rate. N is the number of times that we're going to compound it. And T, of course, is time. Now, as we talk about compound interest is, some banks, it's just simple interest where they give you interest once a year. But other banks, you get your interest every month. So it's compounded monthly. So you only get 1/12 of your interest rate, but you get it 12 times a year. So your rate is growing more often. And then we talked about Euler's number already, the number E, which represents the natural number. And as we talked about, if it did it 10 million, 100 million, however many times per year, he came up with the number E. So if we compound interest continuously, like every fraction of a second you are getting interest, then we have to use the number E. So that's how we came up with the formula A is equal to P times E raised to the RT. So it's very similar to one of the exponential growth equations we use with a base of E. So those are the two different formulas. So when we're talking about interest, if we do it monthly, daily, quarterly, we're going to use the first formula. The only time we use PE to the RT is when we are compounding continuously. So to do this, all we have to do is use an equation, plug in some information, and type it into our calculator. So Ben's going to invest $10,000 into a bank. He plans on leaving it there for 10 years at an interest rate of 4%. How much money is he going to have in the bank if the bank compounds the interest? And then we're going to try annually, quarterly, monthly, and continuously. So 3 of the equations are going to be extremely similar. Continuously, we're going to use the other one. So let's start by coming up with an equation. So the amount of money he has is equal to 10,000 times 1 plus. Now we have our rate of 4%, but it's only going to happen 1 times a year. And then we raise it to 1 times a total of 10 years. And then all you have to do is go type that in the calculator. Just make sure you're careful with your parentheses. So we have 10,000, and then we need to multiply that by 1 plus a new fraction, which is 0.04 for the rate, divided by 1. Now we don't necessarily have to divide by 1, but when we divide by 12 and all that, you're going to need it. Make sure you close your parentheses twice. And now raise it to the 1 times 10, or you can just type 10. Click enter. At the end of 10 years, Ben is going to have $14,802.44. So that's a nice little profit by making a deposit and just forgetting about it for a while. Good luck finding a bank that's going to give you 4% these days. However, it's still nice to think about the fact that if you just throw a large deposit of money in the bank and forget about it for a while, you can have a nice chunk of change when you're done. All right, so quarterly. Pretty much the exact same thing, except for we are now going to give interest 4 times per year. And what that's going to do is change the amount of money we have. So now we're going to divide by 4, but instead we now are going to do this 40 times in 10 years because it's 4 times 10. Now you can type 4 times 10 up there, or you can just do 40. And you got more money. So the more times it's compounded, the more money you get. So now it's $14,888.64. You go try monthly. Give it a shot. So for monthly, the only thing you're going to do is change the n to a 12. It's going to happen every month, so 12 times per year. So now we just put a 12 everywhere we have an n. So then in the calculator, you just change the 4 to a 12 or retype it. The 40 gets changed to a 120. And after you do it, you will have $14,908.33 after you retype that in. Okay? So again, the more you compound, the more money you're going to have. So what happens if we are always compounding every fraction of a second? Now you have to use the PE to the RT. So the amount is equal to still your initial investment, but now we're going to multiply it by E raised to the RT. So our rate times the number of years, which is 10. So now we're just going to type 10,000 second natural log E raised to the 0.04 times 10. And we get the biggest amount of money yet. We get $14,918.25. Okay, so that's just to show you the more you compound, the more interest you get. So the faster things will grow. All right? So last question. Again, we do not know how to solve this algebraically yet. You will learn by the end of this unit. But Sarah wants to invest $1,000 into an account that compounds continuously at 5%. And she wants to leave it there until it doubles her money. How long is this going to take? We talked about something like this in the exponential growth and decay video. Pause it. See if you know how to do it. Click play when you're ready to see it. So, this is what we should have done. We want to double the money, so the final amount needs to be $2,000. And since this is continuously, we're going to have 1,000 times E raised to the rate times time. But that's what we're trying to find, so we have to use T. So, since we don't know how to solve this algebraically yet, we just have to use our calculator again. So we just put 2,000 into Y1. And then 1,000 times E raised to the 5% X. And just click graph. Again, you'll probably have to adjust your window. And we see that they're going to intersect somewhere between, looks like 10 and 20 years. So we just have to press second trace. Go to the calculate menu. Number 5 is intersect. Click enter 3 times. And it looks like it's going to take approximately 13.863 years. So, if you can find a bank that gives you a nice percentage, just throw some money in there, forget about it for a while, and you'll double it. All right? So, that's it for this video on interest. This is Longo, and I'm out. See you, bye.